Okay, Calc 1 students, welcome to the second part of my video on section 2.2. And we're going to do a real brief video in this part where you're given a graph and we just want to make sure that you know how to do your limits. So let's start by looking at, the graph has several places that are sort of interesting. We have the vertical asymptote at 4. We have the break in the graph at x equals 1. We have this, what we would call a sharp point at x equals -2. So let's start here. Let's look at these limits that are talking about -2, which is one of these parts of the graph. So this is a left-hand limit. It's got the negative superscript. So what I usually tell students to do, you don't have to do this, but just to, be clear on what you're doing, we're interested in the limit as we approach -2. So I'm going to make a dashed line through this. I kind of think of that as a boundary. It's like a wall. And if I'm going to do a left-hand limit, I just get on the left-hand side of that barrier and I start closing in. And remember, the answer to a limit is a y value. So right now, that y value is 2. 2.5, it's just getting close to 3. All right, so the value of that left-hand limit is this y value. So that's equal to 3. Okay. Next one has the plus superscript, so that's a right-hand limit. All right, so you get to the right of that barrier somewhere, just a little bit to the right, start closing in. Right now, the y value is 2.5. Where is it going? Okay, now it's like 2.99999, so it's getting close to 3. I like that. Okay, now we have a basic theorem that says if the left and right-hand limits are equal, then this two-sided limit will have to be the same answer. Okay, so basically on a two-sided limit, you're just closing in from both sides, and if they come together to the same point, then that would be the answer to that limit. Okay, next thing I want to look at is moving on. Now we're looking at x approaches 1. So I'll do the same kind of approach. I'll put like a little barrier, vertical line through 1, just to kind of help me with this a little bit visually, right? And then again, what I'm going to do on the left-hand limit, I'm going to close in from the left. It doesn't matter that there's that open bubble there. It's just what is the y value getting close to? Right now, the y value is getting closer and closer and closer to 1. So that's the value of the left-hand limit. Okay. All right, I'll do the same thing with the right-hand limit. Okay, get a little bit on the right of the barrier. Somewhere, start closing in. Look at the y values. As you're doing this, you're looking at the y values. Right now, we're around -2. We're getting closer and closer to this value. So that's approaching -1. Okay, did they go to the same place? Did the left and right go to the same place? No. So if they don't, then what we say is we say this limit does not exist. You can always just abbreviate that as DNE. Okay, all right. And then let's do couple more things here. Let's look at x approaches 3. Not the most interesting part of the graph, but if you look at x approaches 3, there's no break or anything. So the limit, anytime there's no break like this, and we're going to call this a continuous part of the graph or part of the function here when we learn this. The idea is you're closing in from the left and the right, you're approaching -1. Right, so as x approaches 3, you're looking at this function value right here. So the idea with that is it's a two-sided limit. And if it's two-sided, what you want to do is just close in from the left, from the right. They both come to the same place. That function value is -1. Okay. All right, and one more issue. Let's look at 4. 4 is an interesting part of the graph. That's got a vertical asymptote on it. All right, and there's only a couple of things that can happen to vertical asymptote. Anytime you have a vertical asymptote, the graph either goes to infinity near the asymptote or goes to -infinity. There's nothing else will happen on a function around a vertical asymptote. Never. Okay, it's always the same. So this one is a left-hand limit. Get to the left of the asymptote, start closing in. Now, where's this graph going? It's getting infinitely big, okay? It's going on forever. So on that, we just say plus infinity, okay? Technically, you could say does not exist because infinity is not really a number. I prefer that you just get used to saying, okay, that's going to infinity. That's the preference, okay? The right-hand limit, from the right of that's the same thing, okay? From the right of that asymptote, as you close in on the asymptote from the right, that's going to infinity, right? And then the same thing, the two-sided limit, they're both going to infinity from both sides, so you would conclude that's infinity, okay? That's the preference and not the that does not exist. But technically, you could say that it does not exist because it's not a specific numerical value, it's infinity, okay? All right. So pause the video if you need to get anything written down on this and move on to the next page. I would like you to pause the video. Don't wait for me. Just go ahead and do these, work them out, see if you're okay, and as soon as you're done, just resume the video and check your answer. And that'll be the end of this video. We're just going to look at this situation. All right, so just want you to check over these, make sure you understand these. If you got them right, you're done. If not, if you need to listen to what I go through, then you may do that. I'm just going to look at starting at x approaches 6, this region in here. So again, we just focus on that. I drew this boundary. Left-hand limit, okay, you're getting close to a y value of 2. Right-hand limit around 6. Look at this part of the graph. You are getting close to a y value of 5. Therefore, the two-sided limit doesn't exist because they go to different places. Okay. Next region we look at is -8. I drew a boundary vertical line. Closing in from the left, looks like that's approaching -6. Closing in from the right, it's approaching the same place. It's approaching -6. Therefore, the two-sided limit's also -6. Okay. And next region we're looking at is -2. So I drew my boundary. Left-hand limit here is like this. Close in, you're closing in at 3. Right-hand limit, now see, where's this one going? It looks like it's going to infinity. All right, so that one was positive infinity. You don't have to put the plus there, but I'm just doing that to emphasize. Therefore, the two-sided limit doesn't exist since they go to different places. And then finally, the last one was x approaches 10, that region. So from the left, that approaches the y value of 0. From the right, same thing, it approaches 0. And therefore, the two-sided limit 0. Okay, so that's it. Remember, the key thing on this is the answer to a limit, if it exists, is a y value. So you're looking at the y value it's getting close to around the x value that you're approaching. All right, so that's the idea. Okay, so that'll take care of that. Next part of the video, we'll do a little bit more with limits, getting into the more algebraic domain.